Bye.
Which is nice because I have like
Did you get your AMC results yet?
I got 80 out of 115.
That's pretty good. Did they tell you how that compared to everybody else?
No. Like,
This is the only class I've had papers in.
Lucas. Garrett. Alright guys, welcome back. You will need a blank piece of paper today. You will need a textbook, and there was a handout. So if you forgot any of that, please go get what you need.
share it.
Okay, so as I warned you guys before break, we did a couple days of factoring, and I told you that we had one more new section to discuss. Ladies, I need y'all to join us in class, please. There's one more new section that we need to discuss together. So that would be section 5.3. So we are going to spend 3 class periods and then quiz that, and then that will leave us a couple classes to finish up semester exam review and give you time to ask questions and all that kind of stuff.
And we can exempt this, right? For example.
We do allow exemptions, but you have to meet all the class requirements, school requirements, and you have to finish the final exam review. So I believe, I was told that the exemption stuff would open up today. I don't know if it did or not, but you probably need to start checking your student announcements because I know that's only open for 1 week. Okay, so section 5.3, just a heads up, normally we will quiz this as a 50-point major quiz, which means it's like a half test. We have to treat it a little bit differently than we do other sections because it's not this section and then a quiz and then another section and then a quiz and then test all of it. We don't have time to do that. We only have time for one more section. So I will tell you for sure once that decision has been made, but the last few years, 5.3 quiz is counted as a half test, a 50-point major thing. So something to keep in mind. And in section 5.3, it's all about solving trig equations. So let's see. The first 4 examples on our notes today, I can relate those very closely to how you would do those in algebra. And then we need to look at a couple other kind of unique question types that you will see, and then try to get you as much time as you can to practice in the book. Okay, so the first ones directly relate to how you would do in algebra, and it just really amounts to one extra step, one more unit circle step. So the same way you would solve this in algebra, as far as undoing subtract and then undoing times, just because x has become cosine x, those are still your first 2 steps. The front half of most of these questions is no different than you've done in algebra before. You still add the 1 over. You still divide both sides by 2. The difference is, in algebra, you're finished because you know what x equals. In trig, we're going to have to go a little bit further, and because we don't know what x equals, we know what cosine x equals. So we need to think of the unit circle. And I know you guys have had a break here, so you might feel a little bit rusty, but you're certainly still on the hook for knowing where cosine is 1/2. And then the last part of this just depends on the directions. Half the time the directions will look like this, and half the time the directions will look like that. Now in your notes we're just going to practice writing it both ways, each question, but on your quiz and in the book assignment it'll either be this or this. You don't have to do both. Now, when it says give the answers from 0 to 2 pi, that means just list off what they are. So there was one place at pi over 3. X could be pi over 3. And then also x could be 5 pi over 3. Those are the 2 places where cosine's 1/2. And when cosine's 1/2, that's the values that make this true. So if that's the directions, you were done. But when the directions say solve, this implies that it wants all or every solution, not just the solutions within one rotation. Because at pi over 3, you have a cosine of 1/2, but if you go all the way around and then plus pi over 3, if you land in the same spot, you're going to have the same cosine value, so it's still going to be a solution. Or you could go around 5 times, or you could go the other direction 2 times. Basically, you need a way to make sure that you get all the coterminal angles. So the way we do that is we say x could be this or this. And to get all the coterminal angles, we're going to say plus any integer multiples of 2 pi. So that would be like add a rotation, add 2 rotations, subtract 3 rotations, and make sure that you get all the coterminal solutions as well. So first 2 steps, Undo, subtract, undo, multiply. Algebra problem, you would be done. A trig equation, you need to think about where this occurs on the unit circle, and then write your answer like this if this is the directions, or write your answer like that if that's your directions. So the next 3 questions on your notes are going to be similar, where the algebra is familiar to you. So our focus will be on the second half of the question, going from our unit circle knowledge to writing the answers out. Okay, so question 2. This is a quadratic, and if you have forgotten this, anytime you solve a quadratic, you should always put everything on one side set equal to 0. And the main reason for that is because these usually factor. This is why we did factoring for a couple days before the break instead of just diving into this. And there was even the first day I kind of pointed this out to you that this is going to translate very well. If you can get this with guess and check, that is great. If you need to slow down and do product sum or some other factoring method, that's okay too, but you have to be able to factor that. Now, when I compare this to this, the x's have become cosine x's, but it's still going to factor the same way. 2x minus 1 is going to become a 2 cosine x minus 1, and then an x plus 1 would become a cosine x plus 1. The x's are just cosine x's. The logic and thought process behind the factoring is still the same. Now, how did you go about finishing this in an algebra class?
You would like take each
Uh-huh.
x and then like, or like each parenthesis and find the 0.
Okay.
0.
See where each one equals 0, and you can get more than one answer. Still going to do the same thing here. I'm going to set this equal to 0 and solve, and set this equal to 0 and solve. So I know it looks more complicated on the right, but to this point I have not done anything that is really unique to this class other than replace x's with cosine x's. The part that's unique to this section and this class is now, to get this down to x equals, I need to think about the unit circle. I need to know everywhere where cosine is a half. And I just did this on the last question, so I can do a little bit quicker today. But also where cosine is -1. Just like you got 2 answers in algebra, we've got 2 equations to be solved for trig. Where cosine is a half, but also where cosine is -1. So if the directions just want you to list out the answers between 0 and 2 pi, well, there they are. You've got x could be pi over 3, or it could be pi, or it could be 5 pi over 3. If it says solve, it wants you to give all the answers. So even if you're willing to go around the circle as many times as possible. So it's not really harder, it's just an extra step here. So you could say pi over 3 plus anything coterminal, so plus 2 pi n, integer multiples of pi, 2 pi. It could be pi plus everything coterminal, or it could be 5 pi over 3 plus everything coterminal. Now, here's a part that, I don't know, it's not tricky, but there's a little bit more to this question. If you see this question on the quiz and you write this as your answer, that is fine. You will get full points for these 3 statements because these are correct. But it's important that you know that you can actually condense this in this question, and even though you don't have to practice that for me, when you go to check your answers in the back of the book would not have 3 answers here. They would condense this into a single statement. So even if you choose not to do this, you need to be able to read it. What the back of the book would do in this question is it would say, well, we've got 1 at pi over 3. And then because the thing I would have to add to pi over 3 to get the pi, well, what would that be? All right, 1/3 pi plus 2/3 pi gives you 1 pi. And then what would I have to add to pi to get to 5 pi over 3? And then if I added 2 pi over 3 again, do you see how these three solution places? Do you see how they're all equidistant from each other? So the back of the book is going to give this one answer, pi over 3, and then say add 2 pi over 3 in. So either one of those is fine. But this one statement is equivalent to those three statements. So again, even though it's optional which way you write it, you need to, if you got this answer and you see this in the back of the book, you need to know if it's the same thing or not. Likewise, there are times where writing this condensed answer is much more convenient. It's the lazy way, so you kind of want to be able to do that. Okay, so same thing. If we can solve this in algebra, we got this far in trig doing the exact same thing. We had to think about where these two things happened on the unit circle. 0 to 2 pi, we list those spots. Solve means we list those spots plus everything coterminal. And if those points are equidistant from each other, we can condense them into a smaller statement. Okay, so 2 more that have basic algebra before we look at the questions that have a little bit of a trick to them. But this one, this is the one that probably will be the most commonly missed question on the quiz. And I emphasize this every year, and it's still an issue. I know the temptation on this question, algebraically, is to divide both sides by x, and you get x equals 1. The problem with that is that's not the only answer. Isn't there some other number squared that's the same as itself? What would that be? Well, -1 squared would be 1. 1's not the same as -1. What was the other one?
0.
0 squared is the same as 0. So the notes you need to write to yourself, don't ever do this. Do not divide both sides of an equation by a variable. You lose answers if you do that. I'm showing you that work so that you can see you would only get x equals 1, not x equals 0. What you're supposed to do is the exact same thing I said on the last question. This is a quadratic. Quadratics you want on one side set equal to 0. You can treat this as a quadratic. You can put everything on one side set equal to 0. Usually these solve with factoring. This time the factoring is a GCF. So this would be a GCF. Now we can set this factor equal to 0 and solve, set this factor equal to 0 and solve, and I know the two solutions. Over here, I still have to set this equal to 0 and solve to get some solutions, and set this equal to 0 and solve to get some solutions. Now, I'm not to say that this is easy for everyone to solve from algebra, but this should be the familiar part. Okay, once you get to this spot, this is where you need to slow down a little bit. You need to say, let me think about everywhere where cosine is 0. Let me think about everywhere where cosine is 1. And there's 3 locations between 0 and 2 pi that make these two true, which makes this true, which makes this true, which makes this true. There's 3 solution spots. So this spot, should I call this angle 0 or should I call it 2 pi, or does it matter?
0.
Okay, why has it got to be 0? Yeah, Rich.
Because 2 pi is outside of the domain of the cube.
Okay, so specifically right here, you got to pay attention to the directions. The bracket on 0 means you include 0 if it's an answer. The parentheses on 2 pi means you don't include it. It's up to 2 pi, but don't include 2 pi. So we're going to call this 0, pi over 2, and 3 pi over 2. So Depending on the directions, you could be finished. But if the directions say solve, you might have to do 3 more steps. You could say 0 plus 2 pi n. You could say pi over 2 plus 2 pi n. Or you could say, or and, not or, 3 pi over 2 plus 2 pi n. Adding 2 pi n to each of those gets all the coterminal solutions as well. Now, even though these 3 are not equidistant, you can also condense some of this. So, or we could leave this one alone, and then my red dots are equally spaced out by pi. So instead of saying both of these, we could just say x could be pi over 2. And instead of adding 2 pi and going all the way around, just add 1 pi to get to the next spot. Again, you can write all 3 or you can write these 2, but this is how it's going to be written in the back of the book. So that's important because, of course, you guys need to make sure that you're doing it correctly. Okay, any follow-up questions to this one? Okay, now let's look at one more that fits your normal algebra stuff. Just trying to help you pick out some of the common algebra steps. So in question 4, I would expect you to add 1 and divide by 2. So when you see it like this in the textbook assignment, that's still going to be your first 2 steps. You're still going to undo add or subtract first, and then undo multiply or divide next. The part that I'm concerned about is this next step. When you take the square root of both sides, I know you've heard this 100 times before, but you will hear it 100 more times in this section. You have to do plus or minus, or you lost half of your answers. Same thing over here. Square root of sine squared is sine. And because I'm taking the square root of both sides, I need a plus or minus. Now, to be honest, in algebra, this is probably fine. We know what x equals. We're not too concerned on that. But in trig, this is a problem because I don't know on the unit circle where sine is the square root of 1 over 2. So before we can go to the unit circle here, we're going to need to remember how to square root a fraction. Square rooting a half is the same as square rooting the numerator over square rooting the denominator. Square root of 1 is 1. Square root of 2 does not break down. And then finally, that still doesn't look familiar because I have not rationalized. You really want to rationalize it to make it look familiar. So anywhere where sine is positive square root of 2 over 2 or negative square root of 2 over 2 would be a solution. So if we name all these angles, that could be pi over 4, (3 pi over 4, 5 pi over 4, and 7 pi over 4. So that's what you should do if the directions specifically ask for 0 to 2 pi. Just list out the answers between 0 and 2 pi. Again, notice if you don't remember that plus or minus, though, you've lost half your answers. So that's half the points from one mistake. It's an important step. And if it says solve, it wants those answers and everything coterminal to it. So you could say pi over 4 plus coterminal 2 pi n, 3 pi over 4 plus 2 pi n. X could be 5 pi over 4 plus any integer multiples of 2 pi, or x could be 7 pi over 4 plus 2 pi n. And that is fine. Or, do you guys see that we could condense this one into less statements? How many statements do you think we could get away with?
One.
Okay, so let's say the first answer is at pi over 4. This one. What do you have to add to pi over 4 to get to 3 pi over 4?
Pi over 2 integers.
We'll just add pi over 2 once to get to here. The integer would make sure that you keep doing it. So if I add pi over 2, does everyone see we land here? If I add pi over 2 again, does that land here? Okay, if we add pi over 2 again, does that land here? And then if we add pi over 2 again, we start getting the coterminal answers. So we could do integer multiples of pi over 2. Again, completely optional, but this one statement is equivalent to writing out all 4 of those statements. Mathematically, they're the same, so they will be worth the same amount of points on a quiz, but again, the back of the book's going to do this. We're always going for conciseness in mathematics, so you need to at least be able to see that this is equivalent to that. Okay, so quick recap before we start looking at some of the questions that are an exception and we have to have certain tools ready to go to answer differently. So question 1, the algebra part was just undoing, subtract, and multiply. Go to the unit circle, know how to write your answer. Question 2, we talked about solving a quadratic. Put it all on one side, set equal to 0, factor, set each factor equal to 0, and solve. The difference with these question types is you need to go and figure out where that happens on the unit circle and then know how to write your answer. Question 3, I warned you this is one of the most common mistakes. Don't divide both sides by a variable. Do the exact same thing I said 20 seconds ago. If it's a quadratic, put it all on one side, set equal to 0, factor, set each factor equal to 0, and solve. If it's a trig equation, you have to take that to the unit circle and then write your answer based on the way it's asking you to. And then finally, the last algebra hint I would give you, undo, subtract, and multiply, not a big deal, but when you square root both sides, don't forget plus or minus. Also, when you square root a fraction, you need to know that's the same as square rooting the numerator over square rooting the denominator. And then if it's not rationalized, you probably want to rationalize it before it looks familiar. Figure out where this equals this on the unit circle to get this answer, and then know how to change this answer to look like this if the directions ask you to solve instead. So, on these question types, your focus should be reviewing the algebra, making sure that you can still do the algebra, reviewing the unit circle so that you're not rusty from after break, and then practicing either writing your answer like this or like this based on whatever it's asking. Okay, then moving on. So a lot of your questions, maybe even most of your questions are like those, but there are a few trickier questions where we have to be creative on how to do this. Could be like question 5. Now first off, this has a typo here. This is supposed to say cosine x. But this is different than the first 4 because this has sines and cosines. It's got 2 different things going on. So that's almost like 2 different variables. But since these are related in some way, we can get around that. So one of the most important things you guys learned this semester was the Pythagorean identities, specifically the first one. I think you still have this on your desk even by your desk number. But I don't like that this is sine squareds and cosines. I need to change it so that it's all sine stuff or all cosine stuff. So right here, I can figure out that sine squared is the same thing as 1 minus cosine squared. And then I can make that substitution right here. So instead of saying sine squared, I can say 1 minus cosine squared. Does everybody see that substitution I made there? Okay. Now, not to say that this is an easy question, but that's the only thing unique about this question. Now it's a quadratic. We could try to put it in descending order. We could combine the 1 and the 1 to be a 2. This is a quadratic, so we should try to factor this. If this bugs you, remember that you can just change them to x's temporarily if that helps you feel better about it. In an algebra class, I would probably suggest multiplying everything by a -1. You're welcome to do that here too. Just make sure you multiply both sides by a -1. This factors as an x minus 2, x plus 1. So this is going to factor as a cosine x minus 2 and a cosine x plus 1. Set this equal to 0 and solve to find the location of some of our answers, and set this equal to 0 and solve to find the location of our other answers. So where does cosine equal -1? Okay, at pi. So if the directions say between 0 and 2 pi, pi. If it says solve, you should say pi plus anything coterminal to it, plus 2 pi n. Okay, that's the only place where cosine's -1. What about 2? Where does cosine equal 2? Very good. It doesn't equal it anywhere. So again, I know domain and range seems more like trivia type questions, but that's meant to help you. The range of cosine is -1 to 1. You can't get a cosine value bigger than 1. So it's not that I did anything wrong here, it's just that this didn't produce a solution. So that would be it. So again, not an easy question. It's still like solving a quadratic. You still have to use unit circle. You still have to know how to write your answer based on the directions. But the important part of this, the part that you might want to add to your notes, is if you've got sines and cosines in the question, you need to make a replacement. Use sine squared plus cosine squared equals 1 so that you can rewrite the question to have only sine stuff or only cosine stuff, whichever you prefer. So that's one of the other type of questions. Also, we have some that are where x is not just a 1x. It could be like a 2x or like a 3x. And this isn't too much harder, but it does add one extra step to it. So, in fact, this actually came up randomly on a test review in calculus like 2 weeks ago, I think. Just a random calculus question had something like this in here. So what I would tell you guys is pretend like it just says x for just a second and work it this way. Sine is negative square root of 3 over 2 at 4 pi over 3 and 5 pi over 3. Now for these questions, you should probably do the solve first, and you'll see why in just a second. But 4 pi over 3 plus anything coterminal to it, and 5 pi over 3 plus anything coterminal to it. Now, the one extra step is I don't really know what x equals. I know what 2x equals. I pretended like it was an x temporarily for my convenience. But down here, I don't know what x equals. I know what 2x equals. But that's not a problem because I could just divide everything by 2 here. And when you divide something by 2, everything has to be divided by 2, including this. And same with this one. They go from 2x equals to just x equals. Divide everything by 2. And that could be your solutions if it says solve. Now to come up with the solutions between 0 and 2 pi, you probably want to use this. These are like formulas that tell you all of the solutions. So this first one says there's an answer at 2 pi over 3. 2 pi over 3 is an answer. But it says if you add pi to that, you should get another answer. So what is 2 pi over 3 plus pi? Good. Pi is the same thing as 3 pi over 3. So 2 pi over 3 plus 3 pi over 3 would be 5 pi over 3. Is 5 pi over 3 between 0 and 2 pi? Then we need it as an answer. Do that again. Add another pi. 5 pi over 3 plus pi is the same thing as 5 pi over 3 plus 3 pi over 3, which would be 8 pi over 3. Is that between 0 and 2 pi? Okay, how do you know?
Because it's bigger than 2 pi.
But how do you know it's bigger than 2 pi?
6 pi over 3 is 2 pi.
Okay, so when your numerator is twice as big as your denominator, that would be 2, right? So that's too big, so I'm not going to include that as my answer. But I need to go that far to know that I'm done with this first formula. Now I can do the same thing with the second formula. It says there's an answer at 5 pi over 6. And then it says if you add pi, you should get another one. So if I think of pi as a common denominator, that's the same as 6 pi over 6. 5 pi over 6 plus 6 pi over 6 would be 11 pi over 6. That's between 0 and 2 pi, so that needs to be part of our answer. You should add pi again, or add 6 pi over 6 again, same thing. And that would give us 17 pi over 6. Well, 2 pi would be 12 pi over 6. So 17 pi over 6 is more than 2 pi. So I know I'm done with that one as well. And this is why, for these question types, you should start off with the solve, the formula, and then use the formula to help you to get the solutions, because you're not going to get those solutions just by looking at the unit circle. It's too hard in your head to think about what angle could you multiply by 2 and then the sign be that and get every single one. If we start off with this, we can backtrack to that. So we'll look at one more like this. Again, basically I just pretended like it was an x, solved it, realized I solved for 2x, divided everything by 2, came up with these, and then I know how to read these to get those. So if we do the same thing in number 7, I guess we need to undo the basic part first, which would be undo times 2. Temporarily pretend like it just says x and not 3x. And that would be 5 pi over 6 plus everything coterminal, and 7 pi over 6 plus everything coterminal. But you have to catch yourself on this question type. What's different here is this was not really an x. I pretended like it was an x to help me get started. It was really a 3x, which is actually going to increase the number of solutions we get. But start off with that, and then you can just divide everything by 3, divide by 3, divide by 3, divide by 3. And then you actually know what x can equal. And do the same thing here. Divide by 3, divide by 3, divide by 3. And if the directions say solve, you are finished. But if the directions want solve or find the solutions between 0 and 2 pi, we need to try to use these to generate all of those solutions. So one of them, and this isn't as bad as it looks, but one of them would be 5 pi over 18. That's between 0 and 2 pi. And then it says there's another one if you add 2 pi over 3 to that. Now, for my brain, I'm going to want to get this as a common denominator with 18. So times 6 times 6. So adding 2 pi over 3 is the same thing as adding 12 pi over 18. So if I add 12 pi over 18, 5 pi over 18 plus 12 pi over 18 would be 17 pi over 18. That's still less than 1 pi, so that should be an answer. I need to add it again. That's what this n means. You just keep adding integer multiples. So 12 pi over 18 plus, or 17 pi over 18 plus 12 pi over 18 would be 29 pi over 18. Is that between 0 and 2 pi? Yes, because 2 pi would be 36 pi over 18. Okay, so that's still between 0 and 2 pi. So you have to add 12 pi over 18 again, which would be 41 pi over 18. That one's more than 2 pi. So I know I have exhausted this top formula. I've used it until it's past the point of where I'm trying to use it. Okay, now I've got to do the same thing with these. So one of them is 7 pi over 18. Add 2 pi thirds to that, or add 12 pi 18ths, same thing with the common denominator. 7 pi 18ths plus 12 pi 18ths would be 19 pi 18ths. That's between 0 and 2 pi, so that would have to be a solution. Add it again to get to 31 pi 18ths. Add it again to get to 43 pi 18ths. And that one is finally outside of 2 pi. So this is a pretty elaborate example, but it shows you that by putting a 2 next to x or a 3 next to x, you start to get a whole lot of solutions even within one rotation. A lot of solutions that you're probably not going to just naturally think of. You want to know how to set this up, and you want to know how to read this so that you can go this direction with it. Okay, any follow-up to 6 or 7 that you have ready to go? Okay, then let's look at the last 2 examples. We already kind of talked about this one, but it should show up in your homework and on the quiz. But undo times 5, you get something like sine is 5. Sometimes a problem has no solutions. Sine can never be bigger than 1. Sometimes you might undo an add, and same with this one. Both of these have a range of -1 to 1. If you think about the sine graph, the cosine graph, you should remember they only go up to 1, they only go down to -1. Same with the unit circle. As you go around the unit circle, the biggest they can be is 1, the smallest they can be is -1. So it's important to know that is a possibility to get a not possible answer so that you're not wasting your time trying to solve something that can't be solved. Some things have no solution. Okay, and then last type that is just a little bit different that the other notes wouldn't help you with is this one. And I have it say that algebra isn't helpful. That's not really true. It's just that algebra is a very inefficient way to go about number 10. So in theory, the only algebraic way to move forward here, and I don't want to go through this method, I'm going to show you a much more efficient way to think about this. But in algebra, it is fine to square both sides of an equation if you wanted to. But if you insist on doing this, this question is pretty long, because to square this, you would need to FOIL this stuff out. You would have some sines, some sine squareds, and some cosine squareds. So like we talked about a few questions ago, you would either need to change all the sine stuff in the cosines or all the cosine stuff in the sines so that you have one consistent thing. It would be a quadratic. You need to get all the stuff on one side set equal to 0 to solve, factor it, set each factor equal to 0, solve, and you need to understand that in algebra, if you square both sides of an equation, you might be creating extraneous solutions, which means that your solution solves the step before it, which solves the step before that, which solves the step before that. None of your logic, arithmetic, anything is wrong. It's just that it doesn't solve the original problem. So you actually have to check all of your answers to see if it goes that way. That makes that question way too hard. I do not recommend doing that at all. What I recommend you doing on this question is more of a guess and check approach. And the only reason guess or check makes sense here is there's only 4 spots on the unit circle that are separated by a value of 1, because this says sine minus 1 equals cosine. At 0, sine and cosine are 1 apart. At pi over 2, they're 1 apart. It's all the quadrantal angles. Only the quadrantal angles are separated by 1. So I'm just going to guess and check these 4 spots to figure out my answers. So remember, sine is the y value on the unit circle, cosine is the x value. So if I can take away 1 from y and get x, then it's a solution. So if I test 0, take away 1 from y, it does not equal x. At pi over 2, if I take away 1 from sine, it equals cosine. So pi over 2 is a location for an answer. At pi, if I take away 1 from sine, that makes it -1, which is equal to cosine -1. So pi should be a solution. And the only other place that's separated by 1 that might be likely is 3 pi over 2. But if I subtract 1 from sine, that makes it -2. That does not equal cosine, which is 0, so that's not a solution. There's your answers if that's the directions. If it says solve, you need to make sure that you include coterminal angles by doing plus 2 pi n. So I think that's one of the homework questions as well, or something very similar to that. So if you want to go the algebraic approach, go for it. I'd be happy to help you. It's just not what I would recommend, because you're going to have to do like 10 steps and remember to check them, because some of them may not work. Whereas you could just check, there's only 4 spots that are separated by 1 like that. Okay, so next up we need to go ahead and get into the book assignment so you can practice as much of this as possible. Again, we spend a few class periods on this, so it does buy you some time to build up some confidence here. But I would like to start off with, before I put the assignment back up, I'd like to start off with question 5. So if you did not get out a blank piece of paper at the start of class, please go ahead and get that out now. And I like to talk about the first one together because the directions are a little bit different here. The directions for question number 5 don't even want you to solve this one. Number 5 and number 9, I will let you do number 9 on your own. It's simply wanting you to check your answers. So it's saying hypothetically, let's say you solved this, and that would be a little bit harder because there's a tangent, but you could solve this equation just like we did on your notes. But if you got an answer of pi over 3 and you have extra time on a quiz or a test, you should be able to check this, because that means if I substitute it into the original equation, if it's really a solution, it's supposed to give me a true statement. So this in red is what they're wanting you to show your work on. The tangent at pi over 3 is square root of 3. And so you end up with a true statement. So if you had solved this, got pi over 3 as an answer, simply by plugging it in and checking it, you can be sure that it is a solution. And then part B, they want you to plug in 4 pi over 3 to see if it works as well. So tangent at 4 pi over 3 is also square root of 3. So plugging in 4 pi over 3 gives us a true statement, which guarantees that that is supposed to be part of my answer. So they're starting you off with these two so that you can keep in mind that you can always check your answers. Plugging them in, making sure that it works. Even without a calculator, both of those were pretty manageable. So you can copy that one down, but then 9 is the same thing. You don't need to solve it, you just need to plug it in and check it. So your work should look similar to this for question 9, showing that you're checking it. And then when you get to question 11, you can actually start to practice solving like we did in the notes. So I'll give you a few minutes to get started there. Let me put the assignment back up, and I'll mention just kind of glancing. 5 and 9 are similar because they want you to check. The 11 through 27 odd are a lot like the ones we did in your notes, but the directions say solve, so your answer needs to look one way. After that, 29 through 37 odd say find the solutions between 0 and 2 pi. So your answers need to match up those directions. Answers should look differently. We wrote the answers in both ways on the notes, but you only have to write them in the way that it's asking for in the book assignment. And then there's a couple questions where it's not just an x, it's a 2x or a 3x or a 1/2 x. And then I think there's one question that they want you to try in your calculator at the end. So some of these are a little time consuming, but that is what we're moving on to. So let me give you about 10 minutes to do question 9 and to try maybe 11 and 13, and then I'll help out if you're getting stuck on those. Yeah, that top drawer in there, you can help yourself. Also, I'm sure you guys have probably not looked at your semester exam review over the break, but there were a few questions you could not do on your semester exam review, and those few questions are questions that come from this section. So as you guys get close to finishing the book assignment, you may take note that it is on the semester exam review, so even the semester exam will have a question or two of these types. So really the last thing you need to learn this semester, last book assignment for the semester. But these question types do take some practice. It's not something that most people can just do right away. Okay, just about 2 more minutes, and then I'll let you start to ask some questions if you need to. Okay, so I know you've only had time to try a couple, but number 9, checking those 2 answers, making sure that they work, or maybe number 11, or maybe number 13, any of those that you've tried yet that you'd like some help on. Okay, of course, as always, make sure you're checking your answers as you go along, and make sure you're paying attention to the directions. The directions in number 11 dictates what your answer should look like. So you can correct that pretty quickly if you're checking your work as you go. So I'll give you 10-15 minutes to try to get a few more done, and then I'll bug you again for more questions. But if you get hung up on something, you're welcome to ask at any point. Alright, that was not quite 15 minutes, but should have been long enough for you to hopefully find a few that you could maybe benefit from seeing worked out. So, I don't know, 11, 13, 15, 17, 19, any of those you'd like me to go over with you? Yeah. 13? Sure. So, cosine of what angle plus 1 is the same thing as the negative cosine of the same angle. Now, I think I kind of mentioned this in the notes, but just one little strategy here. Anytime you guys see any of these questions that you're having trouble getting started with, it's not a bad idea to just go over to the side and change all the cosine x's into x's. and then let yourself think about it this way and then come back and apply it that way. Because if you were working this, I would think you would probably maybe subtract an x over and divide both sides by -2, which would give you that. And you can do the same thing over here. You could subtract a cosine from both sides and then undo times with divide. And then once you get it down to some trig function equals a ratio that sounds familiar on the unit circle, that's when you should jump over to the unit circle. Carefully pick out where cosine is -1/2, and one location would be 2 pi over 3, and the other location would be 4 pi over 3. And if my directions said give the answers between 0 and 2 pi, that's what I would want to give. But the directions don't say that. The directions say solve. So I need to say 2 pi over 3 is a location, so that angle and anything coterminal to it, and then 4 pi over 3 and everything coterminal to that. They're expecting your answer to be written in that format. These two are not equidistant from each other, so the distance from here to here is not the same as the distance from here to here. So you cannot condense this into a single statement. You need both of those statements. All right, is that enough for 13? Okay. Anybody else that was going to ask about 13 have anything else about it while it's up there still? Again, I don't want to dwell on this too much, but again, the first two questions, they're just trying to plant that seed in your mind that if you did this on a quiz and if you wanted to check your work, you can make sure 2 pi over 3 is an answer by just plugging it in up here. The cosine at 2 pi over 3 is -1/2. -1/2. And you see that you get the same thing on the left and the right. You can confirm that 2 pi over 3 is supposed to be an answer. And if you have any doubt about 4 pi over 3 being an answer, you can do the same thing. Plug that in, and then you can see that it's going to work out the same way. The left is equal to the right, so 4 pi over 3 is guaranteed to be a correct spot too. So it sounds like a lot of work to plug those in and check, but it really shouldn't be. Okay, maybe two more for now. 15, 17, 19. Any of those you've tried? 21. Okay, let me set one more timer and we'll just do about 6 or 7 minutes this time so that there's time for me to actually go over and help you. And then we'll talk about where and how far you need to be between now and Wednesday's class. Also, if y'all have not looked at the schedule for this week, this is a B week, so I will not see you this Friday. You will go to your B classes on Friday, B day classes. is a location plus pi in. But adding 0 doesn't change anything, so they're not writing 0 plus part. And then it's pi in instead of 2 pi in because they're condensing. See how you have this spot and this spot? So they're just taking both of these statements and combining them into one statement. That's fine. That's the same thing. Because you're saying this is a location answer, so you're saying 0 plus 2 pi n, and you're saying this is a location plus 2 pi n, and they're just saying you could just do pi n, because if n is 0, you get this spot. If n is 1, you get this spot. If n is 2, you just start getting the coterminal angles. So this is the same as both of those. That's what I was talking about in the notes. You don't have to write it that way, but you need to be able to at least make sure your answer is the same. I think I didn't have these up, but they should be up now. The class videos, I think when I go over the questions, I think I always talk about that at the end, so. Okay, to give me a couple minutes here to actually help out with a few questions. Is there another question or two I can help with while you're still here? 15? Let's see, 15 is 3 times secant squared of what angles minus 4 equals 0? Okay, so the basic algebra, the part that should not hold you up is you need to undo the minus 4 by adding 4 to both sides, undo the times 3 by dividing both sides by 3, undo the square by taking the square root of both sides. Don't forget plus or minus when you do that, or you lost half your work. We probably need to rewrite this to make it look familiar. The square root of 4/3 is the same thing as the square root of 4 over the square root of 3. And then before this looks familiar to me, I don't memorize secant values, but what you can do is you can take the reciprocal of this side, as long as you take the reciprocal of that side. And so it looks like our answers should come from everywhere where cosine is positive square root of 3 over 2 or negative square root of 3 over 2. And the directions say solve, so I need to make sure we get the coterminal angles as well. So you could say, you can do 4 answers here. You could do pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n, 7 pi over 6 plus 2 pi n, and 11 pi over 6 plus 2 pi n, and that is fine. But that's not how it's going to look in the back of the book, because these two are equally spaced by pi. So they're going to say x could be pi over 6 plus 1 pi n. And then these two are equally spaced, so they could combine those into one statement, like 5 pi over 6 plus 1 pi n. So that's what I would expect it to look like in the back. But the most important thing here, the most easily forgotten part, is make sure you have plus or minus. Otherwise it's going to be real confusing why they have so many different answers than you. Is there something more specific? Okay. Okay, good. I was just making sure I didn't rush to it so much. Okay, so between now and Wednesday, the last time I see you guys this week, I would like you to do, well, I guess if you didn't feel like you got very much done in class, you probably need to do a little bit more to catch up with everybody else. But assuming that you feel like you got about the same amount everybody else did, I'm going to ask that you do a couple more of these for homework. I just mean like 2 or 3, just enough to make your brain think about it another time. And consider doing another question or 2 on the semester exam review. You should be very close to finished with that. And so if you just even did 1 a day at this point, you would finish very easily. But consider trying to do another question or 2 on the semester exam review. As long as you do that, you'll be on pace and where you need to be on Wednesday.